Hello children, good morning. How are you all? Children, in the previous presentation, you all got the introduction about the quantum numbers. Now today we'll be studying in detail about the quantum numbers. In the previous presentation, I have told you that the quantum numbers give you the exact address of an electron present inside the atom. Now, there are four quantum numbers: the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Now, starting with the principal quantum number. Principal quantum number is denoted by n, small n, and it is equal to the integers like 1, 2, 3, 4. It cannot be 0. Now, in class 10th, in 10th standard, you all have learned about the shells. The shells are the spaces around the nucleus where the electrons rotate. You have learned this. Actually, the principal quantum number will tell you about the shell, the size and energy of the orbital. Now, 1 corresponds to K shell, 2 corresponds to L shell, 3 corresponds to M shell, and 4 corresponds to N shell. Second is the azimuthal quantum number. Now, just a minute. See, as I have told you, this principal quantum number is telling you about the shell. Suppose this is the nucleus of an atom. I am showing it to be positive. Now, this is the nucleus. Here, you can say is the shell. You can say this is the K shell. Next will be L shell, then M shell, and then N shell, and so on. Now, second, the azimuthal quantum number, it is also known as the orbital angular momentum, or it can be said subsidiary quantum number. It defines the three-dimensional space of the orbitals. It is denoted by small l. For a given value of n, L can have values ranging from 0 to n minus 1. Like for example, when we have the value of n as 1, then the value of L will be only 0. Similarly, when the value of n is 2, the value of L will be 0 and 1. When the value of n is 3, then L will be equal to 0 to n minus 1, that is 0 to 2, that is it will be 0, 1 and 2. Similarly, if n is equals to 4, L will be equal to 0, 1, 2 and 3. Now, this actually is telling you about S, P, D, F, G, H, which are actually the subshells. Subshells means it is the subdivision. Now, if the value of L is 0, it means the subshell that is present is S. If the value of L is 1, then it is P. If the value of L is 2, then it will be D. If the value of L is 3, then it will be F. For 4, it will be G. For 5, it will be H. Now, for example, suppose we have the value of n as 1. That means the principal quantum number is 1. Then the azimuthal quantum number will only be 0. So, 1, 0 are the values of n and L. That means it is equals to 1s subshell. The electron is present in the 1s subshell. 1 means this, the value of n, and S means this, S means the value of L is 0. Similarly, if the value of n is 2, that is the principal quantum number is 2, then the value of L will be 0 and the value of L will be 0 and 1. Suppose the value of L in this case is 0, then it will be 2s. That means the principal quantum number is 2 and the subshell is 0. 0 corresponds to s. So it will be 2s. Now, if the value of n is 2, then the value of L will not only be 0. Along with the 0, it will be equal to 1 also. 2, if n is 2, L will be equal to 0 and 1. For 1, it will be 2 P subshell. Similarly, if n is 3, L can be 0, 1 or it can be 2 also. For 0, it will be 3s. For 1, it will be 3p. And for 2, it will be, yes. See? For 0 is 3s. For 1, it is 3p. And for L is equals to 2 will be equal to 3d. Now see children, this SPD, what are they exactly telling? They are telling about the subshells, or you can say the orbitals. Now if we are talking about the third quantum number, coming to the third quantum number, the third quantum number is the magnetic quantum number. It actually gives the information of the spatial orientation of orbitals around the axis. In the axis, how they are arranged in the three-dimensional space. Now they are denoted by the symbol ML, the small m and a small l in the subscript. Now, for any subshell, the number of possible values of ml are equal to 2l plus 1. That means how many magnetic quantum numbers are there? You can find out using the formula 2l plus 1, where you have to write the value of l, you will get the value of ml. Now see children, the value of ml will always be equal to, this magnetic quantum number will always be equal to minus L to plus L. Like for example, if suppose the value of n is 2, the value of L will be equal to 0 and 1. And for each value of L, ml will have a value. For L is equal to 0, ml will be 0. For L is equal to 1, ml will be minus 1, 0 and plus 1. Similarly, if the value of n is 3, L will be equal to 0, 1 and 2. That means from 0 to n minus 1. And ml will be equal to, for L is equal to 0, ml will be 0. For L is equal to 1, ml will be minus 1, 0 plus 1. For L is equal to 2, it will be equal to minus 2, minus 1, 0, plus 1 and plus 2. Now children, what happens for when you are writing the electronic configuration, then what you have to do is, for the 0 you have to make one box only. For these 3 you have to make 3 boxes, and for this you have to make 1, 2, 3, 4 and 5 boxes. See, the 5 boxes you have to make, and inside each box 2 electrons can be accommodated. Now, the fourth important quantum number is your spin quantum number. Spin quantum number is nothing. It will just tell you about the spin of the electron. The meaning of spin is, yes, that means the electron is spinning on its own axis. As it is rotating around the nucleus, similarly it is spinning on its own axis also, as it is in case of the planets. The planets are revolving around the sun and at the same time they are spinning on their own axis. Similarly, the electrons also spin on their own axis, and they can spin either left to right or right to left, clockwise or anti-clockwise. Now this spin quantum number, it is a vector quantity because direction is related to it, and is denoted by ms. Now how to show the spin quantum number? The direction it is just defined by showing either an upside arrow or a downside arrow. That means one is clockwise and the other one is anti-clockwise. Now children, there is a question for you. What are the possible number of orbitals associated with the principal quantum number 3? You have to tell how many orbitals are there. Now we can simply find it out using the quantum numbers. One small shortcut formula is also there, that I will tell you at the end only. Now again I am reading the question for you. What are the possible number of orbitals associated with the principal quantum number n is equal to 3? Now see the solution for this. I hope you all are able to see this. Now n is equal to 3. That means the value of principal quantum number is 3. The value of azimuthal quantum number will be equal to 0, 1 and 2. So magnetic quantum number, that is actually telling you about the number of orbitals, will be equal to, for L is equal to 0, ml is equal to 0. For L is equal to 1, ml is equal to -1, 0 and +1. For L is equals to 2, it will be -2, -1, 0, +1 and +2. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So how many possible orbitals are there if the value of n is 3? Yes, it is 9. The answer is 9. Now another shortcut formula to find out the number of orbitals is, you have to make a square of n. The value of n given to you is 3. Just square it, you will get it. You will get the number of orbitals. So square of 3 will be 9. So 9 is the correct answer. You can find it out anyways, but it will be better if you always write down all this, so that we also get to know that you have the knowledge. Now children, there is another question for you. Using the S, P, D and F notations, you have to describe the orbitals with the following quantum numbers. That means you have to write down, you have to describe these orbitals with where the first is the value of n is 2 and the value of L is 1. Now L1 corresponds to what? Either S, P, D or F. Yes, it is P. So n is equal to 2, L is equal to 1 will correspond to 2 P, because 0 corresponds to S, 1 corresponds to P. So it will be your 2P orbital. Now the next is value of n is 4, the value of L is 0. 0 corresponds to S orbital. So it will be 4S. Similarly 5 S, P, D and F. This is 0, 1, 2, 3. So L is 3, that means it will be F. So answer is 5F. For the fourth one will be 3 and 2 corresponds to D. So it will be 3D. So the answer is 2P, 4S, 5F and 3D. Now children, we'll wind up for today, and for the next presentation, before I take your next presentation, I want you all to go through the NCERT question, try to solve them, and in the next presentation we'll also solve some of the NCERT numericals here. Thank you so much. Sairam.